Problem number 11. We want to take each of these angles and write it as a sum or difference of two other angles, and we have to use some of our nice angles, our multiples of 30 or 45. Let's see, 105. I could do that as 60 plus 45. Those are two of our nice angles. They add up to be 105 degrees. 15, actually I could use the same ones. I could do 60 minus 45 degrees, and that makes 15 degrees. 165, I should probably use something bigger. Let's see, how about 120 degrees? That's a nice angle that we have. And plus 45, and that makes 165. We'll see in this lesson some benefit of being able to write other angles using a sum or difference of our nice angles. Problem number 12. Split the single fraction up, then simplify. The reason I can do that is I only have one term on the bottom, so I can easily distribute it into both parts. 5 sine x over sine x cosine x. 2 cosine x over sine x cosine x. In the first fraction, now I can do some canceling. Let's see, the sine x's cancel here. In the second fraction, it's the cosine x's that divide out. And then I'm trying to make this as simple as I can. The first fraction is 5 over cosine x. I don't even have to have a fraction. I can just reciprocate the cosine up to the top. Same thing in the second one. I can reciprocate the sine up to the top as a cosecant. And so I end up with 5 secant x minus 2 cosecant x. Letter B, we'll do our split up thing. Just writing each piece over tangent squared x. And what should I do next? I guess I'm thinking I should maybe write everything using sines and cosines, and then I'll probably have some things I can do. So this first one would be 5 sine squared x on the top, and then the bottom would be sine squared over cosine squared. The other one is going to be 5 over cosine squared on the top, and then the big denominator would be, once again, sine squared over cosine squared. So what I've created now are a couple of complex fractions. I can simplify each one by multiplying by the LCD of all the little fractions. And when I glance across here, I think all the little fractions have the same denominator. It's just cosine squared x. So what I can do then is multiply through the top and bottom of each big fraction by cosine squared x, and that should wipe out all the little fractions. Okay, so let's see what happens here. In that first fraction, I can see the cosine squareds wipe out. So I will have 5 sine squared x cosine squared x over sine squared x. And in the second fraction, both cosine squareds go out. And so I have 5 over sine squared x. Of course, then in the first fraction, the sine squareds divide out, leaving me with 5 cosine squared x. And in the second one, I guess what I could do is I could reciprocate that sine squared up to the top, turning it into cosecant squared x. And I think that's as simple as I can make it. And then in problem 13, we have a couple of other complex fractions we want to simplify. We'll take the same strategy, find the LCD of all the little fractions, and then multiply the big top and bottom by that value. Let's see, some of my denominators are cosine theta and some of them are sine theta, so the LCD would just be the product of those two things, cosine theta, sine theta. So I got to multiply this by cosine theta, sine theta, and I got to multiply this by cosine theta, sine theta. Really, I'll have to multiply 4 separate pieces by that item, so let's be careful. When I multiply the first one, the cosine thetas would cancel out, leaving me with sine theta times sine theta, which is sine squared theta. In the second one, the sine thetas would cancel out, and so I'll have cosine squared theta after I multiply. Down here, let's see, the first one, the cosine thetas would go. So I'll have 1 times sine theta is sine theta. And then the sine thetas are going to go, and so I'll end up with a cosine theta. Can I do anything else? The answer is yes, because what I notice on the top is that I have a difference of squares. 2 perfect squares with a minus sign in the middle. That means it factors in that a plus b, a minus b pattern. And of course that works out really nicely, because then one of those factors on the top matches the only factor that I have down here on the bottom, the sine theta plus cosine theta. So those wipe out. The final answer to this problem then is just sine theta minus cosine theta. Part B is a reminder that we can do the same thing with just plain old numbers. Look at all the little denominators, 2, 3, and 6. The LCD would be 6. If it helps, you could even write the 6 next to each of the 4 pieces that need to be multiplied by it. When I do this multiplication, I won't have any little fractions left. In the first case, 2 goes into 6 3 times. Then 3 goes into 6 twice. 6 times 1 is 6. And in the fourth one, the 6's cancel out, leaving me with the 5. This gives me a 5 on the top and a 1 on the bottom for a final answer of 5.